In 1911, Ernest Rutherford designed an experiment with a thin gold foil target that was bombarded by alpha particles. Now, alpha particles are positively charged particles. We'll discuss them in more detail when we study nuclear physics. After striking this gold foil target, it was noticed that the alpha particles were being detected being scattered in various directions. He placed these screens around the target to see where they would hit. Now, since these alpha particles deflected at large angles, they must have collided with something massive. And this massive object must have been very, very tiny, since most of the alpha particles deflected through much smaller angles. So based on the results of these scattering experiments, Rutherford proposed a new model of the atom. But before I get into this model that you see on the left side, or the right side over here, let's talk about J.J. Thomson's plum pudding model. At this point in time, historically, J.J. Thomson had come up with a plum pudding model. This was developed in 1897. In Thomson's plum pudding model, he assumed that there were positive charge and mass that was distributed or spread out through this plum pudding, or kind of like chocolate chips that are embedded in a cookie. But with Rutherford's experiment, in which he determined that there was this positively charged atomic nucleus, this showed that this model was incorrect. So let's return back to Rutherford's model now. So from Rutherford's experiment, this gold foil experiment, he deduced that there was this very small, very dense, positively charged nucleus. So he proposed a new model basically based on planetary motion. I'm sure you've seen this diagram before. It's based on Rutherford's model, where electrons that you can see orbiting around here revolve around the nucleus like kind of like a small solar system. Ingenious, right? But, well, it failed. And it failed in explaining the line spectra, which I was discussing in the previous video. You see, as this electron revolves around this orbit around the nucleus, it would be accelerating. Why? Well, it's accelerating because it's continuously changing direction. Remember that you accelerate not only if you're going at a constant speed, if you change direction, you have to be accelerating. So classically what this would mean is that as the electron continuously accelerates around the nucleus, it would continuously radiate energy. And as it gives off energy, it would have to lose energy, that electron, which means that electron would eventually spiral into the nucleus. And that's not what happens. Secondly, atoms like hydrogen do not radiate all the wavelengths. Remember, in line spectra, you only get specific wavelengths that you see. You only see discrete ones. So this model failed in that aspect. And so we needed a new model. And we came up with Niels Bohr came up with a model that perfectly worked for hydrogen. And that's in our next video.